Okay, welcome everybody. Today we're going to talk about lesson number 15, and this is about section 2.3, which is a review of all the different kinds of polynomial division. Everything in this lesson should be quite direct and certainly a review, but there are more examples than usual, so you might want to write down as many as you can. So suppose you are given the polynomial 6x cubed minus 19x squared plus 16x minus 4, and you are told that x equals 2 is a 0. A lot of the problems in the book are worded slightly differently, but they all kind of mean the same conclusion. So I want to make sure that you're okay with all the different ways the questions can be asked or told to you. So if you're told that x equals 2 is a 0, the first thing that means is that f of 2 equals 0, which basically means if you plug a 2 in for all the x's and you calculate, you should get back 0. That's the whole point of being a 0. It turns the whole equation into 0. The second thing that means is that the point 2, 0 is an x-intercept of the graph. So it is in fact a point on the graph. Remember that because it's a cubic, there could be potentially 3 real zeros. Some of them could be imaginary, but here we have at least one of them. If f of 2 equals 0 and 2, 0 is an x-intercept on the graph, what that means is that x minus 2, the opposite sign, is of course a factor of the polynomial. And what does it mean if it's a factor? It means that when you take f of x, it can be written as that factor, x minus 2, times some other polynomial, q of x, and there is no remainder. The whole point of being a factor is that it has to divide in evenly, and the whole point of the division is really what this lesson is about. So now that we know for sure that x minus 2 is a factor of this polynomial, we're going to go ahead and go through and do the polynomial long division. We already know that the remainder should be 0, but let's go ahead and do the process to remind everybody and to make sure that it does in fact fit. So again, you might want to write this down. So 6x cubed minus 19x squared plus 16x minus 4, that is going to go under the division sign. Then you're going to go ahead and put x minus 2 on the outside. When you go to do polynomial long division, you're always trying to do first into first. So x into 6x cubed. And so even though you're trying to see how many times does x go into 6x cubed, a better question to kind of think about is x times what would give you 6x cubed? And hopefully it makes sense that that would be 6x squared, which you're going to go ahead and write up at the top. You're then going to multiply 6x squared times both values out on the outside here in the divisor, x minus 2. So that's going to give you 6x cubed, then minus 12x squared. Hopefully you remember back from not just your long division days, but your long division just back in 3rd grade, that when you now go to do the next step, it's subtraction. The way that I always like to remind you that you're doing subtraction is that when you draw the line, you change the signs. Basically, that's your way of making sure that you subtract each of the terms. So the cubes cancel, which they should. Negative 19x squared plus 12x squared, that's going to give me negative 7x squared. And then I like to bring down my remaining terms. Some people just like to bring down the x term. I like to bring down everybody. Now you're going to go again, and again, it's first into first. So x goes into negative 7x squared how many times? Again, a better question would be x times what is negative 7x squared? And that would be negative 7x. Multiply negative 7x times each of the values in the divisor. So that's going to give you negative 7x squared, and then a positive 14x. Again, I like to say draw the line, change the signs. The whole point of the change the sign thing is that you're doing subtraction. So the squareds cancel. 16 minus 14 is 2x. Bring down the minus 4. Looks like you're up to your final round. So again, first into first. So x times what gives you 2x? That would be plus 2. 2 times x is 2x. 2 times negative 2 is negative 4. Draw the line, change the signs, and you should in fact get a 0. Again, we already knew that that should happen because of the fact that we knew that x minus 2 was a factor, which by definition means it has to divide in evenly. I was kind of using these words, but you have to go ahead and formalize it to make sure that you remember. So there are 4 different vocab words. The value down here, in this case the 0, that is called the remainder. The answer that you get up top, that is, of course, called the quotient. Whatever you're dividing by, that is called the divisor. And your original problem is called the dividend. So 4 vocab words, you do have to know what they are. You do have to know how they interact. So again, just make sure that you write them down if you need to. A note about remainders. Obviously, having a remainder of 0 is kind of our favorite because it tells us the most information and it allows us to keep going. But you can have all kinds of remainders, positive, negative, large numbers, small numbers. You can even have remainders that have variables in them. So don't be surprised by any different type of remainder that you get. Continuing on with this problem, now that we know that x minus 2 goes into the dividend, 6x squared minus 7x plus 2 times, we can kind of keep going. So in the next slide here, you can see that I took my original polynomial and I now wrote it as the divisor times the quotient, no remainder required. Then if you look at the next step here, you can see that 6x squared minus 7x plus 2 turns out that that factored farther into 2x minus 1 times 3x minus 2. Lots of different ways for you to get to from point A to point B. Probably you'd use the AC method or whatever factoring tools you have in your bag, but you'd have to be able, of course, to get from the first one down to the second. This is what you would do if the problem asked you to factor completely. Again, your book asks you like a bunch of different ways of doing things that are all kind of in the same ballpark. So it's important that you kind of go through and make sure you know what all the different directions are. So if the problem asks you to factor completely, you would need to make sure that you factor down as far as you possibly could go. The other thing that they could ask you to do is they could ask you to solve. And mostly they would say solve if f of x is equal to 0. So that would mean that after you factored completely, you would go ahead and set it equal to 0. Then you would actually solve for each of those x's. And of course, if you reverse the signs, you would get positive 2, positive 1/2, and positive 2/3. Those would actually be your 3 zeros or your 3 x-intercepts. Notice that those would all have multiplicity 1, which would be important to know if I asked you to graph it. I'm not going to do that right now, but still good to know. So again, factor completely versus solve versus divide. You kind of want to make sure that you know what it's asking. If it just asks you to divide, you're only going to here, factor completely all the way down, and then only solve if it actually asks you to. So then there is something called the division algorithm, and the division algorithm is just how do the 4 different pieces of the equation relate to each other. And again, as a reminder, the original f of x, that's the dividend, the divisor, the quotient, and the remainder. So there are some problems in the homework that ask you to use the division algorithm. And here it is right here. They're going to use f of x for the dividend, d of x for the divisor, q of x for the quotient, and r of x for the remainder. If you count them, there are 1, 2, 3, 4 quantities, which means 4 variables, which means if you know any 3 of them, you can solve for the missing one. So sometimes they give you the D, the Q, and the R, and they ask you for the F. Sometimes they give you the D, the Q, and the F, and they ask you for the R. So as long as you know any 3 of those values, you can go ahead and find the 4th one. Here's something else that the division algorithm tells us. When we actually divide, what we're trying to do is we're trying to divide the dividend by the divisor. So essentially, we're doing f of x divided by d of x. So what would happen if we divided both sides by d of x, since again, that's what long division is actually asking us to do? Well, if you divide f of x by d of x, you just get that. If you divide d of x times q of x by d of x, those d of x's cancel, and you're just left with q of x plus r of x over d of x. And this is basically good to know because this has to be your answer format. When the question says divide, excuse me, which means you're dividing f by d, you have to give your answer as the quotient plus the remainder over the divisor. And this is exactly why, because of the division algorithm. Of course, if there is no remainder, then you just leave it out, but otherwise you do have to give your answer in this format. So what would that actually look like? Well, let's go ahead and do another long division problem here. So you're trying to divide this quartic by this quadratic. Notice that as I go to set it up, 6x to the fourth, etc., that's my dividend. So that goes underneath. X squared plus x minus 1, that's the divisor, that goes outside. Notice that there are no missing terms. It goes exactly from the highest exponent down to the smallest exponent. So no worries about any placeholders. We're just good to go. Remember, when you do these, you're always doing first into first. So x squared times what would give you 6x to the fourth? That would be 6x squared. Multiply that 6x squared times everybody in the divisor. So that would give you 6x to the fourth plus 6x cubed minus 6x squared. Draw the line, change the signs. Fourths are gone. -1 minus 6 is -7 x cubed plus 5x squared. And then again, I like to bring down all of my leftovers at once, but that's kind of up to you. So then go again. X squared times what gives you -7x cubed? That would be -7x. Multiply times everything in the divisor would give you -7x cubed, -7x squared, and then positive 7x. Draw the line, change the signs. The cubes are gone. 12x squared. 9 minus 7 is 2x minus 3. Final round coming up, squared into squared. I know it's the final round because I'm not going to be able to plug, I can't divide a squared into anything less than a squared. So x squared times what is 12x squared? That would be plus 12. So 12x squared plus 12x minus 12. Draw the line, change the signs. So the squareds are gone. 2x minus 12x would be -10x. -3 plus 12 would be a +9. And then again, I'm not able to go any farther into this division because I can't be able to divide a squared into just a linear. So what we can see here is that it does not divide evenly. So x squared plus x minus 1 is not a factor of this polynomial, which it would be nicer if it was, but it's okay that it isn't. After doing all this hard work, don't forget to actually give your answer in the proper format. So to give your answer in the proper format, you're going to go ahead and write it based on the previous slide. You have to write it as the quotient plus the remainder over the divisor. So here are all the different pieces. And then here's just showing you how you would actually write your answer. So your answer would be the quotient 6x squared minus 7x plus 12 plus the remainder, which is -10x plus 9, over x squared plus x minus 1, which of course is the divisor. So this would be one perfectly acceptable answer. Just so you know, what you could also do is instead of having plus that negative, you could also do a minus and make this a positive, and then make that a positive, and then make this a -9. So it would be 10x minus 9 over x squared plus x minus 1. I don't really care either way, so factor the negative out or not, that's up to you. Just make sure that you have it as the quotient plus the remainder over the divisor. You probably have the main idea here, but just a reminder of what you need to do if there are missing terms. We, of course, have to use placeholders, and you can use them both in the dividend and in the divisor. So x cubed minus 9, notice that there is no squared and there is no linear. So I went ahead and put in plus 0 for each of those values. Notice that in the divisor, there was no linear. So I went ahead and plugged in a plus 0x. For long division, these are not required, but they are strongly, strongly, strongly encouraged. If you want all of your values to always line up nicely in columns, you have to use those placeholders or else it's not going to work. So even if you have placeholders, you're going to go ahead and always do first into first. So x squared times what gives you x cubed? That would just be x. Go ahead and multiply by everything. So x times x squared would be x cubed plus 0x squared plus 1x. Draw the line, change the signs. The cubes are gone. There are no squareds. 0x minus 1x is negative 1x, and then bring down the 9. And as you can see here, you're actually not able to go in any more because a square doesn't divide into a linear. So again, this is not a factor of the polynomial because it doesn't go in evenly. How do you write your answer? Well, again, you have to write your answer as the quotient, which was x, plus the remainder over the divisor. So the remainder was negative x minus 9 over the divisor, which was x squared plus 1. Again, that would be a perfectly fine answer, or you could do x, factor out the negative. That would make this x plus 9 over x squared plus 1. Please make sure you know that those are completely equivalent, and honestly, I do not care which version you use, as long as you can get down this far. Perhaps you remember there is a shortcut for long division that is called synthetic division, but the only caveat here is you can only use it if the divisor is linear. So we would not have been able to do this for either of the two previous problems since the divisors in each of those examples were quadratics. You're only allowed to do it if it's linear, and what it means to be linear is that you're dividing by something that's either x minus k or x plus k. We'll review the mechanics of synthetic division in a minute, but hopefully you remember that if you have x minus k, you're going to switch the sign and use k. And if you have x plus k, you're going to switch the sign and use negative k. Something else to remember is when you do synthetic division, the quotient is always, always 1 degree less than the dividend. And you must always use 0 placeholders for missing terms. Again, for long division, it's just strongly encouraged. But for synthetic division, it's a must, or else there's no way you can get the right answer. So a few examples of synthetic division. I want to divide this cubic by this linear, x plus 2. Again, you must only have a single x to the first in order for synthetic division to be legal. So here's a reminder of the process of synthetic division. Step 1, you're going to go ahead and copy just the coefficients. No variables. So 5, 8, negative 1, and 6. Then from here, I like to draw a little box. Because this is x plus 2, you're going to switch the sign and plug in negative 2. Basically, whatever value would make that parentheses 0. Then you're going to bring down the 5. Multiply to the box. So 5 times negative 2 is negative 10. Add the column, negative 2. Multiply to the box. Negative 2 times negative 2 is 4. Put it in the next column. Add that column. Multiply to the box. Add the column, 0. The fact that you get a 0, so again, this is always the remainder slot. If you wind up getting a 0, that means that x plus 2 divides evenly into this polynomial. It doesn't have to happen, but again, we do like those problems the best. In terms of the answer, you have to write it just like you did on the previous long division examples. You have to write the quotient plus the remainder over the divisor. Where do you find the quotient? Well, you find it here. If you refer back to the previous slide, your answer is always, always 1 degree less than it was of the dividend. So if the dividend started off as a cubic, your answer has to be a quadratic. I guess I leave an extra slide for that. So my answer, 5x squared minus 2x plus 3. And since there is no remainder, that is simply my final answer. So again, your quotient is always found here. These are always your coefficients of the answer, and you always start with 1 degree less than the original problem. One last example. So I want to divide this quartic by this linear, x minus 3. Notice that there are several missing terms, so I'm going to have to make sure that I use zeros accordingly. So 3 for the quartic, missing the cubic, -6 for the squared, 4 for the linear, and please make sure you know you do have to use a 0 for the constant. So here you set up your coefficients, no variables. Remember that for this linear, you have to reverse the sign. So 3 goes in the box. Also, if you do your synthetic division slightly differently, some people don't put the number in the box. They put the box around the coefficients. Whatever format you learned it in is fine with me. This is just my personal preference. And then remember the steps. You always just bring down the first value, multiply to the box, 9, put that number in the next column, add that column, multiply to the box, put it in the next column, add that column, multiply to the box, add the column, multiply to the box. So 3 times 67, that is 201. Add. So what we can see here based on the remainder is that x minus 3 does not divide evenly into this polynomial. Again, whilst it's nicer that if it did, it doesn't mean anything, or at least it's fine that it doesn't. Your quotient is found here, and you always start 1 degree less. So your answer to this division problem is 3x cubed plus 9x squared plus 21x plus 67 plus the remainder, 201, over the divisor, x minus 3. So please don't do all that hard work and then forget to actually write the answer in the proper format. The majority of the problems tonight ask you to just divide. So if it just asks you to divide, this is your answer. Only if it asks you to factor completely and solve do you actually go ahead and continue to factor and solve. So I think you're going to see more of that on the next homework assignment. But speaking of homework assignments, here's homework number 15. It's found in section 2.3 on pages 159 to 161 in the book. Again, I think you'll find these problems quite straightforward. Answer key is posted as always, so thanks very much for watching, guys, and we will catch you next time.